Here's our warm-up. If we were all together, we'd be doing this as a warm-up, but I decided to make this a screencast video so that we can move on. This is not a topic that I'm expecting you to get mastery on. It's a topic that I want you to see, to sort of understand, hopefully, but I don't expect you to get mastery on it. So we did problems like this before, so just as a warm-up, I would have you solve with an inequality. So we would subtract 8 from both sides, subtraction property of inequalities, so you'd be left with 2y is less than or equal to negative 8. Divide both sides by 2, and you're left with y is less than or equal to negative 4. And I think we even graphed it, and we said, oh, this is weird. It's a pen that's leaving when they say magic pen. So let's do a problem where we had, if this was a negative, for instance, then what we would have done, remember we said we would divide by a negative 4, and we divided by a negative 4. That would mean that you would flip the sign, and we talked about why that was happening. So then your answer over here would be p is greater than or equal to negative 4. So that's our warm-up problems. Our essential question, how can you graph a system of linear inequalities? So remember, we've been doing linear equations, right? So here's our graph, and maybe here's our two lines, and where they intersect, that is the solution to the system of equations. Guess what? Now we're going to graph something that might have a whole big section that it is true of. The solution set is a whole section of it. This will make more sense in just a second. So if you were with me, if we were in class, would be with a partner, you'd be matching each linear equality with its graph and explain your reasoning. So first off, which line belongs to which one? I'm going to put this in slope intercept because I think that you're probably still most easily able to graph when you put it in slope intercept. So if I take this equation, this first one, and I subtract 2x from both sides, I end up with y is greater than or equal to negative 2x plus 4. So I look at these equations. I know that my y-intercept is 4, so here's my 4 on this A1, and it has a slope of negative 2 down 2 over 1 down 2 over 1. So this one is A, right? But all this stuff that's blue, that's the crazy part, right? So how you would graph that, and this is the part that I am going 100 miles an hour, so I know this is going to be new to you, but if you were graphing this by hand and you were not using Desmos, what you would do is you would graph it like an equal sign. Y equals negative 2x plus 4, which is what we did. It's the blue line. And then I would ask you to put in the point 0, 0. And I would ask you, does that solution satisfy the inequality? So if I put in the point 0 in for y, and I'm put parentheses because it's a substitution, minus 2, and I put in the point 0 for x. So I'm talking about this point right here, the point 0, 0. Does it satisfy the solution? We can see the graph. We know that it should. But normally we wouldn't have that graphed ahead of time. So is 0 less than or equal to, this would be a 0, right? Because negative 2 times 0 is 0 plus 4. Is 0 less than or equal to 4? Yes, 0 is less than or equal to 4, so therefore this side of the graph would be in the solution set. So how you would do it is you would pick a point that's easy to manipulate, and you would decide if it's in the set or not. Let's do the same thing with, let me erase some of this stuff, and let's do the same thing with the second equation. Okay, so the second equation, we have 2x minus y is less than or equal to 0. If I put this in y-intercept, I would have minus y is less than or equal to negative 2x plus 0. I don't need the plus 0. And if I get rid of my negative y, if I multiply both sides by negative 1, I would have to flip my sign, and I would have a positive 2x. So y is greater than or equal to 2x. So I would graph y equals 2x, which is this red line in this one, y equals 2x, up 1 over 1. Stop the video. Make sure you agree. Y equals 2x. And then I can't pick the point 0, 0 because I know that's on it, but I can pick this point, which is still pretty easy to do, which is negative 1, 1. So I can pick the point negative 1, 1 and say, does it belong, does it satisfy, or is it part of the solution set? So I'm going to plug in to negative 1 minus a minus 1 less than or equal to 0. 2 times negative 1 is negative 2, minus a minus 1 is plus 1. Is that less than or equal to 0? Negative 1 is in fact less than or equal to 0, so it would be in the solution set. So we would shade in this side because the point that we chose was part of the solution set. I realize I'm moving real fast. Don't worry. That's how we do it by hand. I'm actually going to ask you to do it in on a graph instead. I mean on Desmos. So if I were to graph y is less than 5 and y is less than 5 and y is greater than or equal to x minus 4, I am going to show you how you would use your Desmos. I actually meant to have that up and ready, so let's just get it ready. And you would go to a graphing calculator. So Desmos.com, you're going to go to the graphing calculator. Don't try to go in where we do our normal things that we do in class. And we said y is less than 5 was one of our equations. So that's what it looks like when you graph it. So it's going to be at y, and notice it is a dotted line because it is not equal to, and y is greater than x minus 4. So there's my two lines. I can see on Desmos where they overlap. So where the two, this whole big triangle right here, where they overlap. So there's obviously an infinite number of solutions. 0, 0 would be one that would satisfy both of these, but the specific question that we were asked is, does the point negative 1, 5, how does that fit in? So where is negative 1, 5? Negative 1, 5 actually does not, because if I look at negative 1, 5, right in there somewhere, I can actually plug it so that you can see right where it is. That's where it is. It doesn't because it lies on the line. It doesn't, it's not the red, it's not included in the red graph because it has to be less than 5. So it's not included. The other way that you would do that is algebraically, you would plug these two numbers into these equations. If y is 5, is 5 less than 5? No. So it does, that was a really weird no. No, it is not. It does work in the other one, as we saw, 5 greater than or equal to negative 1 minus 4. Is 5 greater than negative 5? Yes. So it does work in this one, but not in this one. So it is not a solution to the system. Same thing here. You can graph these. Take a minute, stop this video, graph these, see if this point matches, or algebraically we can plug them in and see if it works. So in my first equation, I would have, if I substitute the y as 4 and the 1 for x, is 4 greater than or equal to 4? Yes, it is. Well, so that's the first equation. My second equation, I'm going to substitute 4 in for y again. I'm going to get greater than or equal to 1 minus 1. Is 4 greater than 0? Yes, so that one would work. If you went to your Desmos and graphed that, you would see that where they overlap, this 0.14 does in fact match in. So I'm going to go down to the next slide that we have here. So graphing the system of inequalities. Step 1, you would graph the inequality in the same coordinate plane. So the same that you would do with as an as an equation. You graph it like you would an equation, but if it is less than, it's going to be a dotted line, just like when we did our open circles. It doesn't belong. If one didn't belong, you would have an open circle. The line that's dotted does not belong to the set because it has to be, because in this case, y has to be less than x plus 2. So the dotted line does not actually belong. Things on the line are not part of the solution set. Everything up to the line, as close as you can get, is part of the solution set. And then on the second one, it is a solid line because there's an equal sign. So because it's greater than or equal, there's a solid line. So in this case, everything that overlaps in the two would be the part that's in the purple. It would include this red line, but it would not include the dotted line. So everything from the solid line up to, but not including the dotted line, the intersection of those two graphs. Okay. Solve this system and graph the linear inequality. So how I would like you to do this is to just go to Desmos and to try it. Okay, so here's my Desmos. Here's my, is this my, that is not the equation, is it? I meant to put these on here. I added a few extra examples that I really didn't need. So graph the system of linear inequalities. Let me go down to this one. I think I thought I put one on here that I already put in Desmos. Let's just go. So in Desmos, I had already put in y is greater than or equal to negative x plus 4, and x plus y is less than or equal to 0. So the question would be, what is the solution set? And if I click on those, you can see that as they get graphed, you can see that there is no solution. There is no solution because they both happen to have a slope of -1. When you were to solve the second equation, you would get y is less than or equal to -x, right? So the solution set would be 0. We already talked a little bit about types of solutions. So in this particular, oh, it's this problem. So in this problem, I need to click on this. This is what the graph looked like. In this problem, if you want to take a minute and graph it in Desmos, you'll see that it looks like this. The part that they overlap is the darker blue, right? They overlap in the darker blue. That would not include the dotted line here, but it would include things that are north or above the solid line, and the same over here. If you were to graph these, you would see that the part that's double thick is the part that's included in the solution set. That's what I want you to know. I want you to know that you can go to Desmos and you can graph the solution set. And the part that it's double overlap is the part that it would satisfy both equations. This one says write a system of linear inequalities represented by the graph. So this is going to be just a little bit different, right? Because you are going to have a line. So I'm going to have to figure out what this line is. And as I look at this line, this dotted line, this dashed line, I can see that the slope is up 1 over 1, up 2 over 2. So I can see that the line is y equals x. Whoops, I did not mean to show the solution. I can see that and I don't think I can go back and get rid of that. As far as I know, let me see. Nope. I might be able to give us a little bit more space. So I can say that that line was y equals x, but it's an inequality. In fact, it's not even equal to. So y something, right? It's something. It's either greater than or less than x. In this case, it is shaded below, so it's going to be y is, well, actually, you know what? Let's not even try to think of it that way. Let's pick a point out here. Let's pick a point that we know is on the graph. In fact, we can pick this point right here, or we could pick a point up here. Let's pick this point. Sorry, let me erase that. the two that we're not going to pick. We're just going to pick the one that I have. So we don't know at this point if it's going to be the bottom or the top. So let's pick the point 0, 1. So we're going to pick the point 0, 1, and we're going to put it into the graph that we have here, where so x is 0. So I'm going to plug in, I'm going to substitute 0, and I'm going to substitute 1 in for y. Is 1 greater than 0? 1 is greater than 0. I don't know what I was just thinking. Scratch what I said, because we were given the fact that it was down. So it's going to be the opposite of what we said, because we were given the fact, we were already given that where it was shaded. So that will not, it'll be the opposite of that, right? So we're going to have this, because it'll be the opposite of what we thought. Or if we want to pick a point over here to know which direction it goes, you could pick this point and you would say that it went that direction. Y would be -1 is less than 1, so we know it goes this direction, so y is less than x. So our linear inequalities would be y is less than x, and our other line we can see is actually going to be y, because it's a horizontal line, y something it's going to be equal to, because it's a solid line, is going to be greater than or less than, or greater than or equal to, or less than or equal to, and it's going to be a -2. So again, you can pick a point that you know is in the region. So I know that the point 0, 0 is actually in the region. So if I put in a 0 for x, a 0 for y rather, sorry, 0 is actually greater than or equal to -2. So I know that that's going to be the direction that my equation goes. So it's going to be y is greater than or equal to -2. There's my system of linear inequalities that I can write given the graph. So given the graph, I can write a system. Here's an example that says you have at most 8 hours to spend at the mall and at the beach. You want to spend at least 2 hours at the mall and more than 4 hours at the beach. Write and graph a system that represents the situation. How much time can you spend at each location? So what do we know? So we're going to reread this a couple of times. So stop the video and reread the question. You spend at most 8 hours at the mall and at the beach. You have at most. So I have at most. If I were to let x be the number of hours at the mall, right? So there's one of them, I'm at the mall, and let y be the number of hours at the beach, then I can start writing my equations. I know that together I have at most 8 hours. So I have less than or equal to 8. That's part of my system of equations. What else do I know? I know that I want to spend at least 2 hours at the mall. Well, the mall is x, so it can be greater than 2, but it can't be less than 2. So x is greater than or equal to 2, because I want to spend at least 2 hours at the mall and more than 4 hours at the beach. So the beach is y, and I know I want to spend more time than 4 hours. So now I have a system of equations with three different equations, and I need to find how much time I can spend at each location. So I'm going to take those. You could easily graph those on paper, or you can go to Desmos, and I preloaded those three equations in there, you'll see. And as I put them on, you'll see that x plus y is less than or equal to 8. This is everything that satisfies this equation is in pink. Everything that satisfies the next equation is in blue. So it could be any time more than 2, right? I wanted to spend at the beach, or was it the mall? And then y is in green. So how much time could I spend? Anything that's in all three. So this number would be in all three because both of those are full lines. So I could spend hours at the mall, 6 hours at the beach, and that would satisfy all my equations. I could take a number in here somewhere like this, anything in here. As I move my line around, I get all of these different anything within this shaded region that's shaded by all three. So I could spend 2 hours at the mall, and I could spend 4.53 at the beach, would satisfy my inkling to want to spend there. It's not the most, but remember, see how you say that, you might be going, wait a minute, that doesn't add up to 8. You're right. But remember, we didn't say it had to add up to 8. We have at most 8 hours to spend. This one has exactly 8 hours. We cannot do this one right at this point because it's 4 and 4, and that does not satisfy the fact that you're going to spend more than 4 hours at one. So because that line is dotted, that green line is dotted, the 0.44 is not included in the solution set, but anything in the triangle that is not on the dotted line is included in the solution set. I feel like I am giving you guys way too much information. But that's the general idea of how you would solve a system of inequalities. Solve a system of inequalities. The last thing I want to do is name an ordered pair. Name an ordered pair that has a solution to the system of inequalities. Name an ordered pair that is not a solution. So one that is a solution is the 0.00. So 0, 0 is a solution. So is -1, 1. So is 1, -1. All of those are solutions. In fact, anything right on the lines are also solutions. So things are not a solution are things that are not inside where it's shaded. So that would be 2, 2 is not a solution. How about 2, is this -4? Is not a solution. How about -3? And, well, anything is not a solution. So anything out here would not be a solution. That is the basic idea of solving a system of inequalities. I'm going to give you some work to practice this, but I really hope that you understand this is so that you see it, so that when you get to Algebra 2, that you've seen it before, when you see it on a CMAS test, if we take CMAS, when you see it on a map test, you understand that a system of inequalities is no different than a system of equalities. They just have a shaded region to satisfy the inequality portion of the function. So that's all.